Hello everyone and welcome to another video. In today's video we are going to review another digital multimeters from the manufacturer ZOYI with the number ZT-225. These multimeters have some excellent features that we are going to talk about first, and then we are going to test it, and then we are going to tear it down to see what's inside. First of all, this multimeter has a very unique shape and form factor. It is the same size as their model M1. This multimeter has some really good features that we are going to talk about. First of all, it has great input protection. If we put a voltage over here and we connect it to the main outlet or a high source of voltage and we put it into the wrong range, we are not going to have any problem with this multimeters. It's protected against voltages on the wrong range and there is not going to be any problem for you. Next one is the capability to measure AC and DC voltages at the same time. This feature is very great when you have some noise inside your system and you want to determine if there is any DC or AC leakage inside your system while you are working on something. Next feature is the warning light for measuring current. While you are measuring current and you are on the current range, there is a light coming up and it will show you that you are on the current range, so you don't accidentally connect this multimeter wrong and have some problems with it. And overall, I think it's a good multimeter in its price range. Another great feature with this multimeter is its high count, and as you know, the higher the count of a multimeter, the better a measurement is going to take and the more accurate that measurement is going to be. So this multimeter with these 25,000 counts is a really good accurate multimeter for its measurements. In the next part, we are going to use our digital multimeter test box to test and measure some values and see how these multimeters behave. As usual, the first thing that we are going to measure is resistance. For measuring resistance, we will put our multimeters into resistance measuring mode. Then we will connect our probes together to see the resistance of these cables. As you can see, the resistance is very minimum and our probes doesn't have too much effect on our measurements. First thing we are going to measure is the resistance of a resistor with the 0 ohm value. Then we are going to go for a 2.2 ohm resistor. Next we are going to go for 22. Next we are going to go for 220, 2.2K, 22K, 220K, and last we are going to measure a 2.2 mega ohm resistor, and you can see the measurement on the display. Next we are going to go for capacitors. The first capacitor that we are going to measure is 33 picofarad, and as you can see, it's not shown as a correct value. Next capacitor is 303 picofarad. Next is 3.3 nanofarad. Next is 33 nanofarad. Next one is 330 nanofarad. Next is 3.3 microfarad. Next one is 33 microfarad. And lastly, we are going to measure a capacitor of 330 microfarad. As you can see, measuring big capacitors takes a little bit of time. Next, we are going to go measure diodes. Before we go to diode test, let's measure continuity. As you can see, it's fast and it's latched. Then we are going to go to diode. As you can see, the continuity mode is shared with the diode measuring mode. Now we are going to measure some diodes together. First diode is Schottky diode. Next one is rectifier diode. Next we have red LED and it's lit up. Next we have orange LED, yellow LED, green LED, blue LED, and then white LED. As you can see, all of our LEDs are lit up and the forward value is shown on the display. Next, we are going to measure some DC voltages. We are going to go to millivolt range and measure some DC voltages. First one is 50 millivolt. Next one is 100 millivolt. Next one is 200 millivolt. Next, we are going to measure 400 millivolt, but for this, we need to change our ranges. Now we are measuring 1 volt, 2.5 volt, 5 volt, and then 7.5 volt. As you can see, measurements of DC voltages is accurate on this multimeter. Next, we are going to measure AC voltages, but for AC voltages, I don't have any standard reference. We just have our mains voltage. I'm going to connect the multimeters to our mains voltage. As you can see right now, we have 228 volt on our mains voltage. There is a very good feature with this multimeter. If you inject a voltage into this multimeter and you put it in the wrong range, this multimeter is not going to have any effect and it's not going to burn up. It's not going to have problems. As you can see, I'm changing the ranges while inputting the mains voltage into this multimeter. And at the end, if we go back to AC voltage, we will see that the voltage is actually shown on the display and we don't have any problem. If you inject the voltage into this multimeter on a wrong range, you don't have any problem. Next, we are going to measure some frequencies and some currents with this multimeter, and then we tear it down and see what's inside. Alright guys, life has been so rough lately, I didn't even remember that we could make AC signals or AC voltages and fed it back to the multimeters to test the accuracy of the AC voltages. For this purpose, we first put the multimeters into AC millivolt and turn on the backlight so you can see better. Then we will start feeding some voltages into these multimeters and we will measure them. Right now we are feeding a 50 millivolt RMS voltage to this multimeter with a sine wave, and we are measuring it. Now I'm going to go for a 100 millivolt. Now I'm going to go for 200 millivolt. Now I'm going to go for 400 millivolt. As you can see, right now we are in the overrange mode. For this purpose, we will put our multimeters into AC voltage measuring mode and we will measure the 400 millivolt with our multimeters. Now I'm going to feed a 1 volt. Now I'm going to feed 2.5 volt. Now I'm going to feed 5 volt. And lastly, I'm going to feed 7 volt. As we all watched, we made some AC voltages using our signal generator and we fed it back to the multimeters and we measured those signals. And as you saw, the accuracy of these multimeters is very good. Now we are going to generate some frequencies using this signal generator and we are going to feed it into these multimeters. For this purpose, we first put our multimeters into frequency measuring mode. Now we are going to generate some frequencies using our signal generator and we are going to feed it to multimeters to see how accurate frequency measurement with these multimeters is. Right now we are on 1 Hz signal sine wave with a voltage peak to peak of 5 volt. Now I'm going to increase the frequency and we are going to see the effect on the signal. Right now we are on 1 Hz. Now I'm going to feed a 10 Hz signal into this multimeter. Now I'm going to feed 100 Hz. Now I'm going to feed 1 kHz signal. Now we are going to feed 10 kHz. Now we are going to feed 100 kHz. Now we are going to feed 1 MHz. And lastly, we are going to feed 4 MHz. As you just saw, we made some frequencies using this signal generator and we fed it back to the multimeters and we saw the accuracy. Now I'm going to replace this signal generator with a DC electronic load. We are going to test some currents on these multimeters and see how well it's going to behave on current measuring mode. Alright everyone, the setup is actually very simple. We have a DC electronic load. that we all know how it works. We are going to set some currents and it's going to draw as much as current as we want. And there's a power supply over here, and our multimeter is just in series between this electronic load and the power supply. I'm going to draw some currents and see how these multimeters behave on measuring the current. Right now we are set into 50 milliampere. I'm going to turn on the electronic load. As you can see over there, we are drawing some currents. I'm going to increase the current to 100 millivolt. Then I'm going to go to 200 millivolt. Now 400 millivolt. And as you can see, we are already over ranging, and we need to correct our probe and set our multimeters into correct range. As you can see, we are drawing 400 milliampere over here. I'm going to increase our current to half an ampere. Now I'm going to increase it to 1 ampere. Let's go for 2. And at the end, we are going to draw 4 amperes of current, and as you can see over there, we are measuring the currents that this DC electronic load is taking from our power supply. For opening this multimeter, first we need to remove the jacket. As you can see, there is some input protection for this multimeter, and we injected some voltage in the wrong ranges, and you see that nothing happens to this multimeter. And there is no COB chip on this multimeter, everything is a normal IC. And this is the teardown. I hope you enjoyed this video. Until another video, catch you next time.